video is going to be about identifying whether a point is on a given line or not. So if I have a line and I want to find out if the point's actually on it or not, how can I know for sure? How can I prove it to myself and probably also others that that point belongs on that line? It's part of the points that make up the given line that I'm looking at. Well, let's take a look at this problem here. So here I have a line, right? And so there's lots and lots of points on this line, right? Like there's a point here that's on the line. There's a point here that's on the line. And technically all the points in between are also on the line. They're just not integer points, right? So there's really an infinite number of points that are on the line. But hopefully you can also see that there are also points up here, right? Or maybe down here or over here that are not on the line. So if I were to randomly pick a point, the question is that point on the line and how can I know for sure? So one way that we could do is I could say, well, is the point negative 4, 0 on the line? Well, I could go ahead and look. So I could say, well, let me look at this point. And so if I look right here, negative 4, 0 sure looks like it's on that line. But sometimes it's hard to tell for sure because sometimes you're, off a little and is it exact? So we want an algebraic way. We want a way to be able to prove that it's on the line so that nobody can give us an argument one way or the other. So let's think about this line as an algebraic equation. Okay. So if I were to write the equation or the formula for this line, right, I'm going to write it in y equals mx plus b form. So the first thing I'm going to find is the b value, and the b value of this line here is positive 2. So then I can use the slope, the idea of rise over run. So here to get between these points, it went up 1 and it went over 2. So my slope is 1 over 2 times x, and that is equal to y. So in other words, my rule is y equals 1/2 x plus 2. So now can I use that to prove that this point, negative 4, 0, that sure looks like it's on the line, is actually on the line? Well, I hope you remember that every point has an x coordinate and a y coordinate. So if this x coordinate, if I were to plug this x coordinate into this rule, the y that comes out should be this y here, if it's on the line. So let's go ahead and test it. I'm going to show you one way that I'm going to test it. I'm going to plug in both values. I'm going to plug in the x, so the x will go right in there, and then I'm going to plug in the y over here for the y. Be careful because there's sort of a twistiness going on here, right? You don't want to get them mixed up. So y here is 0. So my question that I'm asking is 0 equal to 1/2 times x, and x is negative 4, plus 2? So if this equation is true, then whatever I get on the left-hand side should be equal to whatever I get on the right-hand side. So let's just do this arithmetic on the right-hand side and see what value I end up with. So is 0 equal to 1/2 of negative 4? Well, that's negative 2. And negative 2 plus 2 may be equal to 0. And in fact, if I finish that up, negative 2 plus 2 is actually equal to 0. So this statement, right, is true. So when I plug in negative 4, I get out 0. So this point is on the line. And that's good because it really looked like it was on the line, and I didn't want life to be more confusing than it already seems to be. Let's try a problem like this one here. So here I could sort of see the line. I could get a good estimate as to whether my point was going to be on it or not. But at 100, that's way off the edge of my computer screen. So I don't know if that's going to be on this line or not. So I could use similar method. For this one, I'm going to show you just sort of a twist on it. I'm going to use the rule y equals 1/2 x, because we're talking about the same line, right? So y equals 1/2 x plus 2. And I'm going to plug in the x value here. And I'm going to see what I get for y. And if it matches, good. And if it doesn't match, then it can't be on the line, because notice every point, every x value here has only one y value. There's no space where this x value, where this line is in more than one space at a given x place. So let's plug it in. What do I get? What is y when I take 1/2 of 100 and add 2? Well, y, 1/2 of 100 is 50, and 50 plus 2 is 52. So when the input value is 100, the output value should be 52. Put in x, and out should come y. Well, is this the point over here? Is the y value 52? No, it's not. It's 102. So this point is not on the line, because the point that is on the line, the y value that is does correspond to the x value when x is 100. That y value is 52, not 102. What if I don't have a line? What if I just have an equation? Now what am I going to do? Oh, well, I guess that's not too bad, because I can just go ahead and think of it the same way. Think that I've got my x value and my y value. So I could either use the first method, where I plug in what I know. So 9 might be equal to -2/5 of x, and x is 30, minus 3. And now I can check and see, is 9 going to be the same as -2/5? Oh, let's see. Let's make that look like a fraction. And then maybe I can do some cross canceling. So that's -12 minus 3. And is 9 equal to -15? Oh, not the last time I checked. 9's a lot bigger than -15. So that is not going to work out. So this point right here is not on the line. Let's try one more, and I'm going to use that other method. So if this is my x, I'm going to find out what I think y ought to be, and then check and see if this is the point that I've got. So if y is equal to -2/5 times x, and x is -15, which I'll write as -15/1, minus 3, is y equal to this? Well, let's do a little canceling. So that cancels down to -3, and that cancels to 1 in the denominator. So y is equal to +6 minus 3, or y is equal to 3. In other words, when I plug in -15 for x, I expect to get 3 out. So there's a point, -15, 3, on my line. Well, let's take a look back here. Is the expected value 3? And yeah, indeed it was. So this one checks out, right? So this is on the line. Great, I hope that helps, and enjoy your mathing.